right, let's get started with our lesson 8.8, solving logarithms. So by the end of this lesson, you'll be able to solve a logarithmic equation. You can convert an exponential expression to an equivalent logarithmic expression. Okay, so the main idea here is that we are converting and then using our calculator to solve if possible. So here's a little picture of how we convert. If it starts like this, 2 cubed equals 8, we can convert this exponent to a log by looking at the base of the exponent. Here is our base of 2. The 2 becomes the base on a log. The exponent becomes the answer, which when I say answer, I mean the number after the equal sign. And the answer becomes what's inside the parentheses for the log. And this works both ways. So we can think about the base becoming the base, the exponent becoming the answer, and the answer becoming what goes inside. We can also do it backwards by saying the base of the log becomes the base of the exponent. The answer becomes the exponent, and the inside becomes the answer. So I know that probably sounds kind of confusing here, but this is how I want you to think about it. This is our little trick we thought of in Algebra 2 planning. So it is the base and switch. This is what we're going to be learning today, the base and switch. So kind of like the Legally Blonde bend and snap. You bend and snap, bend and snap. But instead of bending and snapping, we're going to be base and switch, base and switch. Okay, and I'll show you that in action right now. So for our first example here, we're going to take the base, and the base becomes the base on a log. So base becomes base. So base and switch. So instead of the exponent here, we're now going to put the 3 here, and the exponent goes on the outside. All right. Let's set up the next one. Well, okay, sorry, I'm getting ahead of myself. Let's just finish this one out. So here we can put this base 19 of 3 into the calculator, and when we do that, we get 0.373 equals, and then we bring down that x plus 4. Now we can solve for x by subtracting 4 from both sides. 0.373 minus 4 gives us negative 3.63 equals x. And if you are a steps person, our steps are over here to the left. Isolate the exponent and its base. Convert the exponential expression to an equivalent logarithmic expression, and then type the log into your calculator and round to the nearest hundredth. That's 2 decimals. Round to 2 decimals. What this means up here, isolate the exponent and its base, that's going to come into play on an example 2. We want this to be isolated. So how can we get that all alone? Well, our first step would be to subtract 4 from both sides. That leaves us with 3 times 1/2 to the x equals 15. Well, now we still want to isolate that base and the exponent, so we need to divide by 3. Now we're left with our isolated base and exponent, and 15 divided by 3 is 5. Now we can do the base and switch. So base and these switch. And now we can solve. Type it in the calculator. So log base 1/2 of 5. When we put that in the calculator, we're going to get negative 2.32 equals x. All right. I want you to go ahead and try the next 3 examples here. I will give you about 4 minutes to do that. And I'm just going to go ahead and let the video continue recording. If you need more time than 4 minutes, please pause at the end of the timer. But 4-minute timer is beginning now. Sorry for the beeping. I'm recording this during my second period conference. And if you are struggling trying to remember how to do the log in the calculator, you're going to hit the yellow control button, and then you're going to hit the button to the left of the number 1, the 10 to the x. Notice how above that button it says log in yellow. If you want to reach any of those yellow portions of the key, you just hit that yellow control button and then hit that key. In your calculator, you should see log with a square down here and a square here. This lower square is where you're going to put your base, and this square right here is where you put what's in the parentheses. Okay, so just a quick little review on that. All right, we got about 1.5 minutes left. All right, 1 minute to go. All right, there's our timer. Okay, 4 minutes have passed, so let's go ahead and go over these 3 examples here. So for the first one, we're going to do the base and switch. Here is our current base, 3, so that is now going to become our base on the log. Then we're going to take the answer and the exponent, and those are going to be switched places. So we have log base 3 30 of x. When we type that into our calculator, log base 3 of 30. And just as a reminder, this is all we're typing in the calculator. We don't ever type equals x into the calculator. You will get an error. All right, so log base 3 of 30, we get 3.09. We said 2 decimals, 3.095, so we're going to round that up to 3.10 equals x. All right, for the next one, we need to have the 10x isolated. There's a 4 there. How can we get rid of that negative 4? We add it. That leaves us with 10 to the x equals 38. Now it is isolated, and we can do the base and switch. Base and switch. This is a reminder, we're taking that exponent and that answer, and they are switching spots on the equal sign. No, the 38 does not become an exponent, it becomes part of the log. Putting that log into the calculator, we are left with log base 10 of 38, that's 0.58. And the last one, again, we need to isolate that 5 to the x, so we subtract 14. We get 5x equals 7. Now we can do the base and switch. Here's our base, 5. So log base 5 and switch. Putting that log base 5 of 7 into the calculator, and we get 1.21 equals x. All right, good job if you got those correct. Pat yourself on the back. Moving on to the next example here. So it says, I can solve a logarithmic equation. You'll be able to know you can do that by being able to convert a log expression to an exponential expression. So this is again another example of how to do that. The base on the log becomes the base of the exponent. The answer becomes the exponent. So again, the base and switch, same steps. We isolate the log. We convert that by doing the base and switch. I don't know what's up with my and sign right there, but base and switch. And then so step 2. Type the exponent into your calculator. Okay, so for example 1, we have log base 7 of x equals 2. So we're going to start with the base, and these two switch. So now we have a 2 exponent equals x. Okay, 7 squared is 49, so x equals 49. All right, for the next one, here, we have a base of 2. Notice how it says x minus 9 in the parentheses. Because it's in parentheses, we cannot touch anything inside the parentheses until we get rid of the log. So your first step here would not be to add 9. No, no, no. We cannot touch the 9 until we get rid of the log. The log is holding everything in the parentheses. Okay, so starting with the base and switch, we have a base of 2, and now these switch. Now we have an exponent of 4 equals x minus 9. Now 2 to the 4, 2 times 2 is 4, times 2 is 8, times 2 is 16. So now we have 16 equals x minus 9. And how do we solve for x? Well, we add the 9 to get rid of it. 16 plus 9 is 25. So x equals 25. All right, next example. Here we do have some items that need to come off of the log before we can deal with the log. So we need to isolate that log. Our first step in isolating the log would be to subtract. 25 minus 15 is 10. And now still need to isolate that log, so we're going to divide both sides by 2. So we are left with log base 2 of x equals 5. Now, time for the base and switch. Base and switch. 2 to the 5. 16 times 2 is 32. So 32 equals x. All right. Number 4. We do have some work to do before we can isolate that log. We need to add, we need to get both of these logs together. So first things first, let's move I would move the 2 to the other side. Well, yeah, this is what I'm going to do. I'm going to add the 2 to the other side. So we have log base 8 of 4 equals 2 minus log base 8 of x. You could also write this as negative log 8 of x plus 2. So you could write the plus 2 on the end or at the beginning. It really doesn't matter. It's the same. Then I'm going to add the log 8x to the other side so we can combine those logs together. Okay, and if you remember from our lesson from yesterday, you remember from our lesson from yesterday, when we have two logs with the same base, the insides are multiplied. Let me say that again. When we have two logs that are being added together with the same base, the two insides are being multiplied. So 4 times x is going to leave us with log base 8 of 4x, and then still bringing down that 2 equals 2. Now we can do some steps. Now we can do the steps of the base and switch. So our base here is 8. So our base of the exponent will be 8. And then we switch these here. So 8 to the 2 equals 4x. So 8 squared is 64. And now we can solve for x by dividing both sides. That is going to leave us with 16. So x equals 16 here. Ooh, that one was a bit of a doozy. All right, for the next one, next page, I can solve a logarithmic expression, or equation, sorry. So for these, your learning target is that you can solve a log equation. So you can condense a log expression and you can use the one-to-one property to set the arguments equal. When we say arguments, we're talking about those exponents. We did this I guess we did this last week when we had that quiz of solving exponential expressions. Same idea here. One-to-one means when you have a log with two logs with the same base set equal to each other, and their insides are different, then the insides can be set equal to each other. So as long as the log and the bases match and they're set equal to each other with different insides, those insides will be the same or equal. So our steps, we're going to use properties of logs to condense the log expression. And if both sides have the same base, then set the values inside of the parentheses equal to each other. And then we can solve algebraically for the variable. All right, so our first example here, we have log base 7 of 3x plus 5 equals log base 7 of 8x minus 12. Notice how our logs match. So we're going to take the insides and set them equal to each other. Now, I prefer to subtract the smaller x from the larger x. That's going to leave us with 5x. Since I canceled out something from the left side, I have to bring something over to the left side. So minus 12 plus 12, that leaves us with 0. And 5 plus 12 is going to give us 17. So 17 equals 5x divided by 5. So x equals 17 over 5. Awesome. Okay. Example 2. Here we have 3 times the log 2 base of x, and that equals log base 2 of 27. So we need to isolate this log. Oh, okay, I see what I'm doing. Never mind what I said there. So if you recall from yesterday, we have a 3 in front, and in our properties of logs, this can now become the exponent on the 3. So for this left side, we're going to change it to log base 2 of x cubed equals log base 2 of 27. Now that our bases are the same, we can go ahead and set those insides equal to each other. So x cubed equals 27. Now how do we solve for x if there's a cube on it? We cube root it. And what we do to one side, we have to do to the other. So now we have x equals the cubed root of 27, which is 3. All right, for the second example, again, still using our properties of logs to condense the expression, we have a coefficient of 2, which can now become the square on the 3. So we can rewrite that as log base 2 of 3 squared, which is actually 9. So I'm going to go ahead and write that as 9, plus log base 2 of 5 equal to log base 2 of x. All right, now what we talked about yesterday as well was that we can, when there's 2 logs with the same bases being added together, the insides are being multiplied. So here we can condense this right side to be log base 2 of 9 times 5. What's 9 times 5? 45. Set that equal to the log base 2 of x. And now we have condensed. We have the same logs here with the same base. So we're going to take those insides and set them equal to each other. X equals 45. All right, as for the last one, we have log base 8 of 48 minus log base 8 of x equals log base 8 of 4. Okay, if you remember from yesterday, when we have 2 logs with the same bases and they're being subtracted, that means we are dividing the insides. So this side we're going to say log base 8 of 48 divided by x equals log base 8 of 4. Okay, now we need to recognize that our logs are now the same, and we can set those insides equal to each other. So 48 over x equals 4. Multiply by x to get rid of that denominator. Now we have 48 equals 4x, and we divide by 4 to get x alone. 48 divided by 4 is 12. X equals 12 here. All right, and that will conclude our notes for today. Looks like the video is approximately 24 minutes long. So since this is not the entire class period, I want you to go ahead and pick up a practice worksheet from the back table with the fan and go ahead and get started on the practice. We will go over the practice on Monday, and if you don't finish it today, we will finish it on Monday. All right. Thank you for following along with the video. Please be good for the sub, and I'll see you guys on Monday. If you need any extra assistance, I will be here Monday morning and Monday after school for tutoring. Okay? Have a great weekend, and I'll see you Monday.